Hello, this is Dr. Stephen Jones. This is the second lecture for Chapter 6, Inventory Control Models. And as I said with the first lecture, the math in this one is not difficult. It's basically algebra. We're looking at theories about how to best manage your inventory, whether you're doing it by purchasing the inventory or you're doing it by producing the inventory. You essentially are trying to keep down the cost of having the inventory, which is the ordering cost, the cost to keep the inventory around, the cost to have a stock out where your customers don't have the product that they're looking for, that you minimize the loss costs that you're going to have just by having inventory out there. All these have to weigh in there together, along with concerns about quantity discounts and other things. So now we're going to take a look. We just did the economic order quantity and basically how that works. And again, it's not difficult. You just have a few numbers you put into an algebraic formula and it comes out with a number. And in that case, we were looking for having 200 items ordered at a time, and that would meet the demand. And then when you got to zero inventory on shelf, you immediately order 200 more units, and they magically show up in your system, and then you've got all the stuff that you need for the next day's customer sales. If that's possible, that's excellent. Otherwise, we have to adjust things out there. And we're going to look at some of those adjustments here in this set of lectures. So, if we assume that we know all of the costs, we know all the demands, we have perfect knowledge out there, then the EOQ is completely, reasonable, understandable as a theory of how to order our inventory out there. However, some of those will be estimations and can vary over time. And as a result of that, there are changes that are going to happen. As this slide says, there are changes that are going to happen. And because we're looking at square roots here, those values are not necessarily going to change a lot when there may be fairly decent variations in the underlying costs. So that's a good thing, and it's also a bad thing. Major changes in your assumptions out there are not necessarily going to have a major change in the result of this process. You might have the same conclusions come out, even though there are vastly different numbers being put into the system. So if you take a look at this example that we just did, the Sumco pump example, and you determine, we go back here, to increase the ordering costs. Suppose now the supplier has upped their costs, and we just had minimum wage level increases for our own staff, and our paperwork goes up that we have to report to the state and federal government regulators, and it all jumps up the cost for ordering from $10 to $40 per order. Notice that has some increase here in terms of our economic order quantity, 200 units to 400 units. And that seems like a lot. It's not that much, but it seems like a lot. And so we have increased our ordering cost by 4 times, whereas we only doubled the size of our economic order quantity. And so the square root portion here minimizes that effect. We could have assumed that quadrupling any of the costs should quadruple the order quantity, but it doesn't with the EOQ. So understand that sensitivity here is going to be affected in different ways by different numbers that are going into the system. And this is definitely true on the bottom. Take a look right here. If this 0.5 goes to 1 or to 2, which doesn't seem like a huge amount, it will have an effect on this number as well. And it would tend to drive these numbers down. Higher costs here will lower this kind of cost, whereas higher costs here will increase the cost. And so if you had a combination of those, you might stay with the same EOQ, even though there were vast changes in what your ordering and handling costs were. Okay, reorder point. When do you reorder? That's also important, not just the cost of it, but when do you reorder? And why is that important to you? Well, because you don't want to run out of product. Now, if you go along with EOQ's assumption that whenever you order, you immediately get the stuff, and if that's possible for you, then a reorder point's not that important as long as you don't oversell all at one time. But if that's not the case, if it's going to take you a little bit, then you need to look at a reorder point, which gives you some lead time out there. So the reorder point is how much demand is there on a day-by-day basis, and then how long does it take you to actually get your inventory delivered to you. So if you cannot get instantaneous under a just-in-time inventory system, if you can't do that, then you need to make sure that you have enough on hand, and this is going to tell you what the reorder point is. From these graphs you can see essentially your reorder point needs to be based on what the lead time is right here, and if that lead time needs to get exaggerated a little bit because it's a longer period of time between when you get orders and when your inventory is brought up, you may need to have a higher amount that is on hand for you, a safety stock, as it were, and we'll get to that in just a moment. So, if your annual demand is 8,000, your daily demand is 40 units, and it takes you 3 days to get this stuff, well, the annual demand doesn't actually show up immediately in this process because we've, factored it into the average demand and the daily demand out there. So you don't need to worry about the 8,000 units. You need to worry about the 40 units a day, and that it takes you 3 days to get your inventory, which brings you around to 120 units. Now, if your order quantity is 400, okay, that doesn't change. This 120 units is not how much you're ordering. This 120 units is when you get on the shelf that you only have 120 units left, you immediately make your 400 unit order quantity. Place that order for 400 units because it's going to go down fast enough that you are going to, because of your lead time out there, you're going to run out by the time the inventory actually shows up on the floor. I know this from my own personal experience. I ran a truck stop in El Paso, Texas. I may have told you all about this. And we used to do our cigarette orders because there were lots of cigarettes being sold in the truck stop. And we would have to make a count every week as to how many cartons and how many packs of, I don't remember, it was like 24 different brands, sizes, flavors, boxes that we had on hand. And our lead time was actually pretty long. It was about 6 days because we would have to put an order in and then it would take 6 days before the truck actually showed up. So we had to know in advance how much we were going to sell. And so we kept records just on paper and pencil in a notepad of how much we had on hand, and we figured over a long period of time whether our inventory was staying relatively stable. So we didn't try to use the EOQ on this. We'd already actually practically put the EOQ in there where we were trying to keep a basic amount of stock on the shelves. Because if we ordered too much, we just had to put it out where the coats were, or stick it behind the time clocks or whatever. And if we didn't have enough, then we had some angry truckers that were going, "Why in the world is my box of Marlboro 100s not here? I need one of them." If we had somebody came in and ordered a carton of cigarettes, 10 packs of cigarettes, that was fine. It was a great sale. On the other hand, it may have spiked a chance for us to have a stock out pretty quickly. And so we had to keep good records of how much we were selling each week for each flavor and box and size and whatever, to minimize the chance that we would run out or that we would have too many on hand. Now, if you took a look at this with the next slide, if your lead time goes from 3 days to 12 days, then here's a real problem for you. And I'm going to tell you this happens. Not necessarily because the entire thing goes off the rails, where you've lost a supplier, which happens. But sometimes it's because delivery times are off. I know that if you don't remember when federal holidays are and you're getting something sent to you through the U.S. Postal Service, you're going to be a day off. That could be pretty harmful if it's checks that people are expecting, or if it's materials that you need to put out there. And you might say, well, if there's a federal holiday, then your people aren't going to be working anyway. In my truck stop days, we were open 24/7, 365. And some businesses are open 365. And so there are going to be times when you have businesses that don't shut down for holidays, and not factoring holidays in, or not factoring bad weather in, if there's major snowstorms or floods or whatever, not factoring those possibilities in could run you into problems. And so there have been times when our inventory was delayed because trucks shut down, or suppliers' warehouse burned, or something along those lines. And while this might not be a long-term change from 3 days to 12 days, by all means, if you're not watching what conditions are and then be able to adjust, it looks like things are going to be delayed a week, whatever, you're going to find yourself out of stock, and you don't want that to occur. Now, if you don't have instantaneous receipt, in other words, if you can't get stuff delivered all at one time to you, and this happens, especially if you're doing production as opposed to ordering materials from an outside supplier who can just drop ship them right to you. If you don't have instantaneous receipt of all of the materials that you're looking for, you need to be careful that your reorder point, your economic order amount, and so on like that get adjusted for this kind of a process. Notice as you're looking at this grant right here, the inventory production time is that kind of time. It's going to show up over here too. Instead of having, as we had in this graph, where the time is, yes, there's lead time, but when the product shows up, it goes up immediately. We don't have that in this graph. It goes up gradually. And yes, you're going to have a reduction in inventory because of customer demand, and you know what that's going to be. But every time as this is going farther and farther down, you need to have a production going up. You need to have some level of production here so that you don't completely run out, and you're building up your inventory here, and let it run out, build it up, let it run out, build it up, let it run out. And that is the non-instantaneous receipt model out there, or variation on this EOQ model. Now, if you're doing production, instead of looking at that inventory ordering costs out there, you have different costs that show up, and that includes such things as setup costs. So to set up a production run is a certain cost to you. That could be to refurbish some production machinery. It could be hiring staff to get things ready, and these are periodically working for you. They only work during production runs, and so you've got to go out and hire new people. Whatever it is, there's setup costs that come in as opposed to the ordering costs that we had when we were doing supplier inventory. Production run models are also then adjusted. You again will have a similar system here. Now we are running on a production model as opposed to the ordering out of catalog kind of a model. And you want then your optimal production quantity instead of your economic order quantity. Same concept, slightly different variables here, but essentially you're very, very close to the same process. So in this process then, pardon me, I'll go back one more. In this process then, you're still going to get a quantity, and you're still going to have to consider your reorder time. But your reorder point is now a reorder to your own production processes point, as opposed to your reorder to an outside supplier point. Now, what if quantity discounts make a difference? And a quantity discount might make a difference because you find yourself where ordering a higher number out there gets you a lower per unit price. And so we will now have a total cost including a material cost. And this will work for, to some extent, for production as well. But your material cost, whether it is that you're purchasing material that you then use in production, or your material cost that you simply, like my cartons of cigarettes out there, if ordering 10 cartons of cigarettes is cheaper per carton or per pack than ordering 5, should I do that? Well, there are things that go up. By ordering 10 instead of 5, I'm increasing my carrying costs. But have I reduced the cost per item of material costs as such that that outweighs that other cost? Well, let's take a look. Using the same kind of concepts, we still have ordering costs and holding costs out there. Now we factor in that my cost of the product is going to drop as I order more and more. You can calculate this out then. I don't like that curve. That curve is just a little bit too, it's not confusing to me. It's just, it's busy. Take a look. Here's what it says. That this is the total cost curve for discount 1, or essentially no discount, the 0 discount. But it switches for discount 2 because you happen to have, if you go to this level of 1,000 units, it now drops the total cost to this, whereas your EOQ is still here, and for curve 3, your EOQ is going to be over, actually it's over here, but the way this curve is drawn, it would look like it'd be about in here. For both of them, actually, as I remember the numbers out there, it's actually going to be down in here. So this curve is drawn a little bit off, but you get the idea. So this is the total cost curve for scenario 1, scenario 2, scenario 3, based upon the number of items that you're actually purchasing. Use this quantity discount process. It's not difficult. You're going to compute the EOQ for each level, for level 1, 2, and 3. And then you're going to adjust those prices. So now you still have 2 times your annual demand times your ordering costs. But now what you find is that you're also putting in the cost here. This cost here, the carrying cost, hasn't changed, but now the per unit item is thrown into this. And with no discount, it's 5 per unit. With the discount here for the second level, it's $4.80, and discount for third level is $4.75. Now, what that does then is it's changing your EOQ. So now, without a discount, it's at $700. With the first discount, $714, and the third discount, $718. Notice, as I said, all of those are actually down in here, no matter how these curves are drawn. So, you can't order $714 though and get the $4.80. You can't order $718 and get the $4.75. So what you're going to have to do is adjust those quantities. Because you can order the 700 and get no discount, that's fine. To get the discount at quantity 2, you're going to have to order 1,000, and for 3, you're going to have to order 2,000. Even though your EOQs didn't say that, you still have to order the minimums on those to get those discounts. So you say, okay, let's factor that in. And then let's take a look at what our total cost is going to be. So if your total cost right here is going to include the unit price, how many you ordered, what your annual material costs are, ordering costs, and carrying costs are. The material cost here is what your annual demand is times what your unit price is, okay? And so if you order it without discounts at the 700 level, it's going to cost you $25,000 in material costs. 480 is going to be $24,000, and 475 is going to be $23,750. Now this is on the same number of units each time, so our number of units hasn't changed. It's going to be times the material costs. But this is also impacted by our ordering costs and our carrying costs here. And what it comes out is that, yes, taking a discount is good, but you don't save money by ordering at $2,000, because your cost now for carrying, while the ordering cost per unit goes down, you have almost doubled your carrying costs, and that throws this whole thing out of whack. Because this discount here is not enough to overcome the doubling of your carrying costs. Now, if this was lower, and you might be able to then go to your supplier and say, hey, instead of dropping it a nickel here, whereas you dropped it 20 cents here, how about dropping it to 20 cents? You might find that this then becomes competitive. The 2,000 becomes competitive. But that's just something you have to take a look at. It's going to depend on the situation. Safety stock is what you're using with your reorder point to try to be sure that you have enough product on hand so that you don't have a situation like this where you're actually running out of product. This is some period of time, a day, 2 days, hours, that you don't have product on the shelf. And so those are no sales, and you don't like no sales, and it's potentially loss of customers. So instead, if you maintain some level of safety stock, then if it takes longer for you to get your inventory replenished than you thought, or if production times are delayed, or if you've missed a holiday or whatever, you have some level of safety stock here that customers can still buy into until you get your reorder point. That's all for this one. I'll see you in the next lecture.